talking about cracking passwords offline. In previous videos, we talked about extracting passwords in a variety of different forms, including taking advantage of command injection vulnerabilities in a web application to access the Etsy password and potentially the Etsy shadow file. Talked about the use of Mimikatz on Windows to extract files from various places where they're stored on the system. We looked in the Windows registry and in files created by browsers to store passwords. And so depending on the source of the passwords, some of them will be plain text. Some of them may be extractable using utilities on the system. As we saw with Google Chrome, we could use the crypt unprotect data API function to decrypt the passwords. Or some of them might be stored as password hashes. We could see this if we open up a terminal and cat the Etsy shadow file there. So doing so here, we see, for example, for the user account, we have this long garbled string as opposed to an actual password. It's an example of a password hash. And so in this video, we're going to talk about cracking these password hashes with John the Ripper. And so first we need a list of password hashes to crack. And luckily, CoreLogic Security has kept a repository of password hashes from a previous DEF CON challenge, Crack Me If You Can. So if you go to contest-2012.corelogic.com, you'll be on this page. And if we scroll down through the page, we'll see this download the password hash file bundle. Click there to download it to the downloads folder on your Linux system. Then we'll go back to the terminal and take a look at what we've downloaded. So change directory to downloads, take a look, and we see that we have a CMIYC 2012_password_hash_files.tar.bz2. So we're going to need to extract this with tar jxf cmic, pass that to it, give it a moment to extract, and then type ls. What we see now is we've got a directory that we can visit, where if we look inside, we see a list of different files containing hashes. And so looking at these, we see a variety of different they're not quite file extensions, but a value after the hashes dash. And these indicate different types of hashes from different sources. So for example, hashes 3 is encrypted using DES. Hashes 13 uses MD5, which is a weak, broken hash algorithm. Hashes 7 uses NT, which is a Windows hash algorithm. They use NT or NTLM for NT LAN Manager. Let's start out with a simple one. So we're going to take a look at this MD5 hash file using John the Ripper. And so John is stored in user sbin John. And this, in the simplest form, you can run it simply by providing the file name. So I'm going to run it on, hashes 13.md5.txt. Hit enter here, and it's going to load in the file. So it's assuming that's MD5 crypt. There are 6,777 password hashes, all with different salts. So if you're not familiar, salting is designed to make password cracking more difficult. In the past, password hashes were simply the hash of the password. And so very simple, if you guessed a password, it's very easy to determine if it's the right hash by just hashing that particular password. And so you can do this live, or you could do it in advance using what's called a rainbow table. And so a rainbow table was simply a list of hash values and their associated passwords. And so with access to a rainbow table, it would be very easy to crack password hashes because all you need to do is look up the appropriate hash value. In order to make this more difficult, we now have the concept of salts. So a salt is a random value appended to a password before hashing. This random value is shared openly in the file storing the password hash, and its purpose is to simply make a rainbow table more difficult to do. You'd need a unique rainbow table for each salt, and so with that large number of salts that you potentially need, generating rainbow tables becomes more computationally infeasible. Turns out it's simply better to crack hashes online. And so I'm going to terminate this here, and let's take a look at the results of MD5 so far. So we see John says that there's 6,770 different password hashes, all with different salts using MD5. It's starting out with the single rule. And so the single rule in John the Ripper is designed to try permutations of the username. So for example, if you have a username admin and password admin, then it's going to detect that. If you think you're being clever by substituting special characters or simply inserting them in, maybe you use admin exclamation point instead of simply admin, John uses a variety of different mangling rules to deal with those cases. And so by searching through all of these cases first, John the Ripper tries to catch the low-hanging fruit. Those passwords where the password and the username are essentially the same. After that, it tries testing with a word list. So a list of common passwords derived from data breaches, password dumps, etc., where if a high percentage of people use the most common passwords, you can crack at least a few different usernames and passwords very quickly using John. And in most cases, this might be enough for an ethical hacking engagement. Could be that there are 30 admin users on the system. You only need one of their passwords to achieve initial operational objectives. If your goal in the long term is to crack all the passwords just to demonstrate that the organization has a poor password policy, go ahead and do that. But you can do that offline in parallel on a different server while taking advantage of that first cracked password to achieve other objectives. And then the third stage of John, so we see we were on stage 1 of 3 here, is to perform a brute force guessing attack. And so it's going to start with short passwords, try all different permutations, and keep on going. And so John will never stop running with a brute force password guessing attack. What it does is it continues to lengthen the password until it finds all of the passwords. And so if someone's using a strong password, say 16 characters, fully random, John's going to run forever. And so there are a variety of different hash functions as we see up here in our list of hash files. I'm going to open up hashes7nt.txt to demonstrate some of the idiosyncrasies of different hash functions. So NT, as I mentioned, was designed by Microsoft for Windows. And so we're going to run user sbin John and pass it hashes.7.nt.txt and hit enter here. And so give it a moment to run. It's going to get started. And then very quickly, it is identifying tons of different passwords. And so a password here would be in this left column with the associated username. And so what we're seeing here is a case where many users have the same empty password. And it's easy to determine with NT because in NT, if you have an empty password, it hashes to the exact same value. And so it's common to test with NT that value early in the process because you see all of these different default usernames with empty passwords. give this long enough to run, it'll eventually reach a point where it starts detecting real passwords. Starting with weak ones, it'll move through all the weak ones and then eventually perform a brute force search on what's left. I'm going to terminate this with Control-C, and then going to demonstrate one more thing associated with John the Ripper that's really useful for password cracking on Unix systems. And that is the unshadow function. And so if I do unshadow, provide it with links to the Etsy password and Etsy shadow files, I can create a file that John can ingest for password cracking. So I'm going to just drop this to mypasswords.txt. Run that, and let's open mypasswords.txt. And so what this is a file that uses the Etsy password files and Etsy shadow files to format the accounts here in a way that John can ingest. And so if I was performing password cracking on this file, which we'll see in a second, it'll focus on the root and user accounts as the only two that actually include a password hash. So close that out. We'll run user sbin John, provide it with mypasswords.txt, hit enter. It loads two different password hashes, is running through them, and is going to start out again with single, ran through single, determined that these passwords aren't a variant on the username itself. Then it moves on naturally to word list using John's built-in dictionary. Also possible to provide other dictionaries to John if, for example, you have reason to believe that a particular username or password is likely to be associated with, particular username is likely to be associated with a particular password. Maybe, for example, you performed recon on a particular target, you know their favorite sports team, you know children's and pets' names, etc. Can provide those all to John for word list mode and see if they've used some variation on that. If nothing matches there, it's going to move on to brute force password matching and password guessing, where it simply starts out with a short password and builds up to a longer one. And so I'll tell you now that neither of those accounts have an easily guessable password. And so we're just going to be sitting here a while if we try to run it all the way through. So I'm going to terminate that here and tie up this video. And so what we saw in this video was the use of John the Ripper for password cracking. We have a long list of password hashes provided by this CoreLogic contest from 2012. When we open that up, we see a variety of different hash types. We see MD5s, SHA-1s, DES, etc. And so John is capable of ingesting these hashes and performs a series of attacks against them, starting out with single, so mangled usernames, then passwords based off of word lists, and then finally random brute force. So invite you to try out your own passwords with John the Ripper. If you want an easy way to extract them, create users with them on a Unix system, use that unshadow command and feed them in like we saw here at the end, and see how long your personal passwords stand up against password cracking. Thank you.